We are going to start a new topic, that is the partial fractions. Yeah, that's it. So, yeah, right, we will start. That is it. So anyway, when you're discussing about these partial fractions, yeah, then some of you have done this topic, those who are doing the further maths, but anyway, we just brush up work. Yeah, the topic is partial fractions. Partial fractions, right? Okay. Now, what do you mean by this partial fraction? Is suppose that you get some kind of a fraction like this. You get 3 over x plus 1 plus 2 over we have x plus 2. So if they ask you to simplify. So in this case, what you're supposed to do, you have to take the LCM of these two fractions. That is x plus 1 into x plus 2. So you can say 3 times of x plus 2 plus 2 times of x plus 1. That's a fraction where we need to know, right? Okay. Then if you simplify this, you get the answer 3x plus 6 plus 2x plus 2 over, this is turned out to x plus 1 times of x plus 2. So with that, you can say 5x plus 8 over x plus 1 into x plus 2. That is what you learn in our IGCSE and as well as in our small grades even. We just learned this one, right? Okay. The partial fraction is the opposite process of this. They ask you to like this. The partial fraction is just like this way around. They used to give us this fraction. 5x plus 8 over x plus 1 into x plus 2 is given. You need to make them into partial fraction. Write as partial fractions. Partial fractions. Or they might give the question like this. Or they might give you this question, this part of this here. Right, find A and B such that 5x plus 8 over x plus 1 into x plus 2 is equals to A over x plus 1 plus B over x plus 2. So whatever the way they ask the same question. Okay. Now let's see how to answer this kind of a question, right? Okay. So you may be given the question like this. 5x plus 8 divided by x plus 1, x plus 2, right? Okay. Initially write it as per the, you can say the denominators, right, with the addition. Just split the denominators. Split the denominators. What are the available denominators are x plus 1 and x plus 2. Those are the available denominators we have, right? Okay. Then you can say, just put two letters you like. So here they have put A and B. So I'm also just putting it as A plus B. Then take the right hand side. What is the right hand side? Is this bit of this side of it. Then take the LCM of and simplify over here. So you can take the LCM is x plus 1, x plus 2. Then you have to see whether A multiplied by how much. How to find the what is the number to be multiplied with A? Just cover this denominator from here. Okay, I just choose a different color. Right, okay. What is the denominator over here is x plus 1. Cover x plus 1 from this fraction. What is the remaining term? Remaining is x plus 2. So you can multiply with x plus 2. Right. Then, yeah, then plus B. To see what is the fraction over here, what you need to do is you just cover the denominator over here. What is the denominator over here is x plus 2. If you cover x plus 2 from here, from here, the remaining is x plus 1. So you can say it's x plus 1 from the denominator. From what you need to consider from this common denominator, we need to find this one, right? Okay. That is equals to how much? You can say 5x plus 8 over x plus 1 into x plus 2, right? Okay. Now here children, you can see these denominators are similar. Therefore, you can equate these two numerators. You can equate these two numerators. That's the logic of doing this question. So you can say 5x plus 8 is equals to A times of x plus 2 plus B times of x plus 1. That's a way of doing this today. Okay, right. Then let's go ahead with this. Now I need to find the value for A and B. So this is the way of doing it. We use the method called substitution figures to get the A and B. So you can substitute any facts and form a two simultaneous equation and do it. But the easiest way is if I need to find A, over here, I need to cancel out this term. I can cancel out this term by, look at this. If you substitute x equals to -1, then what happened? This is turned up to -1 plus 1, then turn up to 0. Then b into 0 turn up to 0. So simply you can get that answer. Okay. Then if you substitute -1, what do you get? 5 times of -1 plus 8 is equals to a times of -1 plus 2 plus b times of -1 plus 1. So it's turned up to -5 plus 8 is 3. This is -1 plus 2 is 1. It's 1a. -1 plus 1, 0, 0. We just cancel out over here. So you get the answer for a equals to 3. Then if I need to find the answer for a, right. So that means I have to cancel out this term. This term. Therefore, what you need to do is, if I need to find B, I just made a mistake. It's not that. To get B, you need to cancel out this term, this term. To cancel out this term, if I make this one equals to 0, you can totally cancel out the same technique what I have used. Therefore, I have used x equals to -2. So you can say 5 times of -2 plus 8 is equals to a times of -2 plus 2 plus b times of -2 plus 1. So it's turned up to -10 plus 8 is -2. This is 0, get cancels, minus b. Therefore, you can say b is equals to 2. So now simply you can write this answer in this format. You can say 5x plus 8 over x plus 1 times of x plus 2 is equals to 3 times of x plus 1 plus 2 times of x plus 2, literally similar to the first expression. So you can just go here. You can see the same thing you come across, right? Okay, so I just go up here. So you can say 3 and 2. So you can see that is correct. So that's a literary way of doing this. Right? That's the first level of this question. Right? 1 second. Yeah. Yeah, that's the first level. First level means you come across two fractions. If I just another example, just like this, we will get some kind of like 3x plus 2 over, we will get x plus 3 and 2x plus 1, right? Okay, write it as a partial fraction. Write it as a partial fraction means it's the way of doing it, right? Okay, so initially just get, we will write 3x plus 2 over x plus 3, 2x plus 1, right? Okay, then you can write this one as a over x plus 3 plus b over 2x plus 1. What I did was I just split this one as a two different fractions and wrote two different letters. Now our objective is to find the what do you call that, denominator. So you can write, find the variables a and b. That's our objective. X plus 3 and 2x plus 1. Then you can write this is a times of 2x plus 1 plus b times of x plus 3 over x plus 3, 2x plus 1. Let's see how to work out over here. I just get the LCM. Then if I want to find what is the number to be multiplied with, a cover x plus 3. Cover this number from this denominator. If you cover, what is the remaining term? If you cover x plus 2, answer remaining is just like this. If I, just a different one. If I cover x plus 3, the remaining term is 2x plus 1. So you have to multiply a with 2x plus 1, right? Then if I want to find the other one, what you need to do is cover x plus 2, 2x plus 1 from here. Then if you cover 2x plus 1, the remaining is x plus 3, multiply b with x plus 3, that is the step. Okay, yes. Then that's how it comes. Yeah, right, that's it. Yeah, then let's try to simplify this. So what happened here? If these denominators are similar, you can write the numerators must be definitely similar. 2x plus 1 and, sorry, plus b times of x plus 3. Right. Then this is pretty simple. What you need to do is, I need to find the value for a. If I need to find the value for a, I have to cancel b. Then I can just substitute x equals to minus 3. Then see, 3 times of minus 3 plus 2 is equals to a times of minus 3 times of 2 plus 1 plus b times of minus 3 plus 3. So this is turned up to 0 and cancel it off. 9 plus 6 minus 7 is equals to minus 6 plus 1 is minus 5a. Therefore, a is equals to 7 over 5, right? Okay, right. Then what you need to do is, then you need to find the value for b. To find b, I need to cancel a. I need to cancel a, sorry. So if I need to find this one, I have to cancel this. To cancel this, I just put x equals to minus half. How do you find this figure? Just make this 0, then you can see the value you need to be substituted, right? So you can say just like this. 3 times of minus 1 over 2 plus 2 is equals to a times of 2 times of minus half plus 1 plus b times of minus half plus 3, right? So this is turned up to 3 and half. It's plus 2 is 1 and half, 1 over 2 is equals to, this is get 0. So it's still like, if you just work out 2 and half, 5 over 2a, 5 over 2b, sorry. Therefore, you can say b is equals to 5. Let me see whether it's correct. 3 into half is minus 3 and half. It's plus 2 is, yeah, but any mistake I just made it?
Sir, no, can we like substitute A equals 7 over 5 to get B also?
If you substitute 705 into a and you have to put another substitution. No, because anyway,
2x.
you mean about over here, there is no, you cannot do it with a, because anyway, just, no, you can put it a equals to 705, but you have to substitute a different figure over here and get another equation. For that equation, you can substitute 705. It's not a problem, right? So this is 3 to 2 is 6. It's 5 over 2. So b equals to 5 with it, right? Then you can write this way. Then this one become a is 7 over 5 times of x plus 3 plus 5 over, this one become 2x plus 1 with it. That's the answer for that. That's the way of getting this answer. Okay, right. Now, yes, that's it. 25. So what is the numerator over here? Let's simplify and see. Yes, I feel some kind of a mistake. Let me see the problem. It's 3x plus 2. So you just put 2 times of a to 2x plus 1 is equals to x plus 3. And if I put minus 3 plus 3 is 0. That's correct. Minus 6 plus 1 is minus 5. Minus 9 plus 2 is minus 7. It's right. That's great. Okay. If you put half, if I put minus half, 3 into minus half is minus 3 over 2 plus 2 is half. This is minus 1, just cancels. Minus half plus 3 is plus 5 over 2. So this is just great. It's sort of, yeah, that's it. So that's the answer for that. But it's not a problem there. Yeah, that's great. Okay. Then but the next level is you come across 3 fractions just like this. Then you get 2x plus 1 over, they might give 3 divisions, x plus 1, x plus 2, and x minus 3. So here, there's one thing we need to understand when you're working out with this, you might get this kind of fractional answers. You always, it not should be integers like this. So sometimes you might get it. So you have to write like this way around for that kind of situations. That's the factor you have to understand from this question, right? Then over here. So how do you do this question? So you can say 2x plus 1. This is x plus 1, x plus 2, x minus 3. So you have to split into how many fractions? There are 3 divisions. So you can write 3 of them. That is, you can say a over x plus 1, b over x plus 2, and c over x minus 3. Right, okay. Then put there you have to take the LCM. So you can write 2x plus 1 over x plus 1 into x plus 2 into x minus 3 equals to here, but this is the point you have to understand, right? Okay. Then if I take x plus 1, x plus 2 and x minus 3, right? Okay. What is the number to be multiplied with A? That is important. What is the number to be multiplied with B? That one also important, plus B. And what is the number to be multiplied with C? Again, how to find the number to be multiplied with A? This is the denominator over here, this one. Cover that one from here. If you cover that, what is the remaining term? It's turn up to x plus 2, x minus 3, right? Okay, B. Right. I just get a small separation because we need more space on that. Other than that, it's not enough. Plus C, right? Then cover x plus 2 from this denominator. If you cover x plus 2, what is the remaining term? If you cover x plus 2, the remaining term become x plus 1 and x minus 3. X plus 1 and x minus 3 with C. Cover x minus 3 from this denominator. If you cover x minus 3, what would be the remaining term? The remaining term would be x plus 1 and x plus 2. That's a factor to understand from this question. Now again the same thing, you can equate the numerator terms since they are similar to each other, right? Okay. Then you can write this is 2x plus 1 is equals to a times of x plus 2 times of x minus 3 plus b times of, okay, but they right, okay, then you can say this b times of x plus 1 x minus 3 plus c times of x plus 1 x plus 2, right? Okay, then what you need to do here, then if you need to find a, I need to cancel both of these terms, this term and this term. If you need to cancel both of these terms, see whether what is the common term available there. That is x plus 1. You can see it's x plus 1 is common here. Then if I make this common term 0, you can cancel this b and c at once and you can get an expression in terms of a. So I will substitute x equals to minus 1. So you get 2 times of minus 1 plus 1, that is a times of minus 1 plus 2 and minus 1 minus 3. So here you can say this term becomes 0 and this term also becomes 0. Therefore, this whole term become just cancel from this expression. So no need of wasting time on writing that. Right, okay. Then you can write minus 2 plus 1 is minus 1 is equals to minus 1 into minus 4 is plus 4 for a. Sorry, it's minus 4, eh? It's minus, yeah, yes, minus 4a. Therefore, a become minus 1 over 4. Okay, let it be. Right, okay, that's great. Then what you need to do is, if I need to find b, I need to cancel a and c at once. See whether what is the common term for both of them. That is x plus 2 is common.
Sir,
Yes, Pute, what is it? Is there any mistake I made?
is it plus 1 over 4?
Sorry?
Plus 1 over 4.
Plus 104, no? It's plus 104, right? That's great. Thank you. Right. Okay. Then if I want to get B, I need to cancel A and C at once. The common term for those is x plus 2 and x plus 2. So I just make it 0. I just put into minus 2. Then you can say 2 into minus 2 plus 1 is equals to, then A and B just get turned up to 0. Right with B. B times of minus 2 plus 1 minus 2 minus 3. So it's turned up to minus 4 plus 1 is minus 3. This is minus 1 into minus 5. Minus 5, yeah. It's turned up to 5b. 5b. Minus turned up to plus, yeah, that's it. Therefore, b become minus 3 over 5. That's great. Okay, let it be. Then if I need to find c, Pute, then I have to see whether what is the common term for a and b. So what is that, Pute? X minus 3 is common for them. Therefore, I just substitute x equals to 3. So you can say 2 times of 3 plus 1 is equals to c times of 3 plus 1 times of 3 plus 2. So it's turned up to 6. 6 plus 1 is 7. This is 4. 4 into, sorry, 4 into 5 is 20. See, therefore, C become 7 over 20, right? Okay. Then what you can write? Then you can write with these fractions, right? Okay, I'll just make it a little bit smaller, then it's easier for me to get it. Right. Then A is how much? 1 over 4. So you can write 1 over 4 times of x plus 1. B is minus 3 over 5. Minus 3 over 5 times of x plus 2. C is 7. 7 over 20 times of x minus 3. This would be the final answer for this question. That's a way of doing it. Is that clear? Hopefully, yes. So, right. Okay, I'll just make it a little bit small, then you can see the full question at once. Right. Okay. If I go to the previous pages, it's the complete answer for this, and this is it. That's a complete answer for this part of it. Then we come up with this question, this is a complete answer for that. And for this question, this is a complete answer for that. That's how it comes. Right. Okay. Then let's go to another question. Then another type of question. That is a second. We did 2 variations. What is the first variation? First variation is with 2 different denominator has in 2 different fractions. 2 different fractions. Here also another example for that. And the second variation is denominator contains 3 fractions just like this. And this the fourth variation is the other important part. The fourth variation is just like this. For the denominator, you get a repeated factors. I just write like this way. X plus 1, the denominator is x minus 1 squared into x plus 2. That is a fraction, right? In this situation, what you need to do is, this is the way of getting it, right? So you can write x plus 1 over x minus 1 squared and x plus 2 is equals to, you have to write, this is the way. If there's a power term, you have to write all the minimal orders including that power. This one's turn up to x plus 1 squared plus x plus 2. Hope you can understand. If you suppose that if you get x plus 1 to the power 3, then you write x plus 1 squared, x plus 1 cube, and x plus 2, right? After that, you can put letters like this way around, A, and A. Sorry, A, B, and...
No, shouldn't it be x minus 1?
Yeah, why I'm doing that kind of silly mistakes? That's great, thank you. Okay. Then yeah. Then how to work out with this, right? Okay. Then I can write x plus 1 over x minus 1 squared, x plus 2, right? Here, you have to be a little bit careful when you're taking the, what do you call that, LCM. LCM is the highest order of x minus 1 is this. So I've just write x minus 1 in this format. X plus 2, the same thing I written over here. LCM is x plus 1 squared. I just write it here. There's a reason for me to write like that way around. Let's see how to get it. A plus B and plus C. Hope you have understood how I did this, right? Okay. Then you have to see whether which number to be multiplied with A. Just cover x plus 1 from here. If I cover x plus 1, what is the remaining term? Remaining term is another x minus 1 from here. X minus 1 and x plus 2 is remained. Right. Okay. B. What is the denominator over here? Denominator over here is x minus 1 into x minus 1. So you have to cover both of these, because the denominator here contains x minus, there are 2 x minus 1s. The remaining term is x plus 2. C, just cover x plus 2. If you cover x plus 2, the remaining term is x minus 1, x minus 1. Right. Then, since the denominators are similar, you can equate the numerators. X plus 1 is equals to A times of x minus 1, x plus 2, plus B times of x plus 2, plus C times of x minus 1, x minus 1, right? Okay, that's the answer for that. Okay. Let's go ahead with this. Right? Then you can say Now, if I want to find A, see whether is there any common term for B and C? No, there is no common term for B and C. Just if I want to find what you call that B, let's see whether is there any common term for these both of them. Yeah, you have. That is x minus 1 is common here. Then I can just put x equals to 1. Then what do you get? 1 plus 1 is equals to, here it's turned up to 0. Here also it's turned up to 0. So you can say B times of 1 plus 2. So it's turned up to B is equals to 2 over 3. Right? Okay. Then let's try to find out the value for C put there. To find C, I have to cover up. I have to cancel these two at once. That is x plus 2 is a common bracket. Therefore, I just put x equals to minus 2. So you can say minus 2 plus 1 is equals to, these two get cancelled. This one also get cancelled. C times of minus 2 minus 1 minus 2 minus 1. So it's turned up to minus 1 is equals to 9C. Therefore, C become minus 1 over 9. Now we have a doubt. What is the doubt we come across is how to find the value for B and C. We can find it. There is no, to find A, there is no common terms come across with B and C. In that situation, you can substitute any figure for this question. So you can just put except 1 and minus 2, which is already used over here. Right. Then I just, the easiest way I can just put it is x equals to 0. If it is used in previous step, you cannot do it here, use a different figure. So if you want to put minus 1, minus 3, plus 2, whatever the value you can put it, but substituting 0 is kind of easy. That's why I'm using this for this. That is turned up to 0 plus 1 is equals to A times of 0 minus 1, 0 plus 2, 0 plus 2, 0 minus 1, 0 minus 1. So it's turned up to 1 is equals to minus 2A plus 2B plus C. Right. Now I know the answers for B and C. That is what you Aushadhi asked me in the previous question. Yes, you have to generate another equation and do the substitution. But if you have a direct substitution where we can cancel all other terms, we go ahead with that approach, not using a different one. Other than that, again, you have to form another equation and to simplify for it. Right. Okay. Then you can say 1 equals to minus 2A. We don't know the value for A. 2 times of B. B is 2 over 3 plus C. C is minus 1 over 9. So if you simplify this 1 minus 2A, this is 4 over 9. So it's just turn up to 4 over 3 minus 1 over 9. So it's turn up to, if you take the LCM, it's 12 minus 1. It's 11 over 9. 11 over 9, right? Okay, so if you go ahead with this, it's turn up to, if you brought it to other side, 1 minus 11 over 9. 1 minus 11 over 9 is equals to minus 2 over 9. So it's done to minus 2 over 9 divided by minus 2 is 1 over 9. So that is the answer for A, right? Okay. Then simply you can write your answer in this format. So we just got into this A. A is 1 over 9. 1 over 9 times of x minus 1. B is 2 over 3. Plus 2 over 3 times of x minus 1 squared plus C. C is minus 1 over 9. So I just, you can put minus 1 over 9. Minus 1 over 9 times of x, we got as x plus 2. Yeah, x plus 2. So this is the final answer for that. That's a way of doing this kind of a situation, right? So you should be able to do this kind of questions as well, right? Okay. Now, if you move up to the exercise, they might give the same thing you need to work out. So here, there's the one example over here. Then this one is another one. So with the 3 fractions, so you can follow up those as well. Now you need to find the partial fractions for these one separately. When you're working out with this, initially to factorize this denominator. So this is turned up to, if I just write, this is x minus 1, sorry, this is x minus 4, x plus 1. Here, x into x plus 4. This is x plus 3, x minus 2, like that you can do it. Here also, it's the same thing. All these questions are just similar. Yeah. Okay, so here also you have to do the same thing, because just keep it as a numerator doesn't make a difference. So you just factorize it. If you factorize it, what do you get with it? X cube minus x means if you factorize it, what do you get with it? I just use a different color for that. If you factorize it, this is turn up to this part I'm just referring to. If you take x out, x squared minus 1, so it's turn up to x times of x plus 1, x minus 1. That's the way of getting it. Right? Over here also you have to do the factorizing, and you can do it. So it does make a significant difference for that. Right? Okay. Just a repeated factor question where we done before. If you have like a couple of the same thing, it comes. Yeah, so that is how it comes for these kind of questions, right? Okay, then yeah, that's it. So you can do up to here. Yeah, improper fractions. Okay, just okay, you can do up to here, but not the improper fractions. Improper fraction should be done as a next topic, and you can finish up to exercise 2B, right? That's a way of doing that.